In this lecture, we studied the CC configuration, common collector configuration, where the collector terminal is common for the input and output. Now here I am taking the transistor. This is a NPN transistor. Base is the input terminal and emitter is the output terminal and collector is a common terminal. This is a collector common terminal. And we need to apply the bias. How to apply the bias? We know that for the emitter need to apply the forward bias. So now here NPN transistor, this is NPN transistor means emitter is N material, base is P and collector is N. So to apply the forward bias to the emitter, now here N should be connected to the negative plate and positive plate is to the ground. And through the resistor we are connecting, and to measure the current we are connecting one ammeter, and to measure the voltage 1 voltmeter. This voltage parameter is VCE. This is at the output side, and this is the variable supply, and the supply name is VEE. Now coming to the input, here base and collector junction we need to apply the reverse bias. So how to make reverse? This base is a P material. By giving the negative plate of the battery, we can make this input reverse bias. Now here this supply name is VBB, and through the resistor we are connecting this supply to the base, and base current is in the order of microamp, and to measure the voltage we are connecting one voltmeter. This is the VBC. This is the diagram, and collector we have to make it ground. This is a circuit diagram for the common collector configuration. But this diagram we are not going to use for the practical purpose. This is for only theory. If we wanted to design a common collector amplifier by using common emitter configuration only, we design. So instead of taking the connecting the resistor, we connect at the emitter and take the output at the emitter terminal. So this is only for theoretical analysis, this diagram we are using. And if we see the characteristics, for the input characteristics, keep the output voltage fixed and vary the input supply and observe the input current, input voltage. And if you draw the graph for the input parameters VI, then you are going to get the graph like this. And on the x-axis we are taking the input voltage VBC, and on the y-axis the current is input current IB. This is IB current and VCB on the x-axis and y-axis. And if we plot the graph look like this. Now why as we increasing the input reverse voltage, now here if you see IB current is reducing. So this is also early effect, what we studied in the early effect. As the output voltage, reverse voltage increases, then the effective width of the base reduces, thereby IB current reduces. That also you can observe here. You can see here. This is about the input characteristics. Now coming to the output characteristics, how to obtain? Same again, by keeping the input current constant, and vary the output supply and observe the output voltage and the output current. So here on x-axis, we have taken the output voltage VCE, and on the y-axis IE, and by keeping the input current is nothing but what? IB. Now if you see the graph, this graph is almost same as a CE configuration. So that's why this CC circuit we don't use practically, because the output characteristics same as a CE, and by connecting the load at the emitter, we can obtain the CC amplifier. So this is only for the theoretical analysis. And if you see the H parameters for the CC, H parameters same again. By using these input characteristics, 2 parameters we can obtain. By output we can obtain 2 parameters. And input here, input impedance, it is the ratio of change in input voltage to the change in input current. Now here the input voltage is, VBC, and the input current is IB. By keeping the output voltage or VCE constant, and similarly reverse voltage gain means output current, output voltage by input voltage. Reverse means what? Input voltage by output voltage. So it is the ratio of change in input voltage to the output voltage by keeping the IB constant. So if you see here, VRC is equal to delta VBC by delta VEC by keeping the IB constant. Now similarly, from the output characteristics we can obtain the two more H parameters. Forward current gain. Forward current gain means what? Output current divided by the input current. So what is output current in this? Output current is IE, output current is IE and input current is IB. Now this is IB. IB is equal to, we are fixing. So we take the ratio of this output current to the input current by keeping the VCE constant. VCE constant. This is the another third parameter. So this is about the forward current. And output admittance. Again, admittance means it is a reciprocal of the impedance. What is the formula for the impedance? It is a ratio of voltage to the current. Admittance means ratio of current to the voltage. Now here HOC means it is a ratio of change in output current to the change in output voltage by keeping the input current constant. That is delta IE by delta VEC by keeping IB constant. These are the four parameters, H parameters for the CC, common collector configuration.